All right, here we are in lesson 2. We're going to talk about position, velocity, and acceleration today. We've already talked a little bit about these, but we haven't done a lot with acceleration up to this point. So when we talk about position, our position function is s of t. So if they give you an s of t, that's the position function, and it usually may say something like, let s of d be the position. The other one that we see when we talk about s of t, you might also see x of t. That's sometimes used for position as well. V of t is the velocity function, which is basically the derivative of position. And keep in mind, position is like measured in feet or inches or something like that, whereas velocity is a speed. That's how fast your position is changing. So that's always, feet per second, miles per hour, something like that. And so if I have a velocity function, I can get back to the position function by taking the integral of v of t dt, and that will equal my position function s of t plus some value of c that we talked about in our previous unit. The acceleration function, that's the second derivative of position, which happens to be the derivative of velocity, and that's going to be measured in feet per second squared or miles per hour squared, and that's how fast your velocity is changing. And again, just like I can go from velocity back to position, I can go from acceleration. So if I take the integral of the acceleration function with respect to t, I get the velocity function plus some value of c, some constant value of c. Okay? So remember, speed and velocity are synonymous when they're positive, but speed is always positive, whereas velocity can be negative. If your velocity is positive, you're moving to the right or up. If your velocity is negative, you're moving to the left or down. When we talk about finding average velocity, okay, notice the formula here. This uses the position function. So average velocity uses position function, and average acceleration uses the velocity function. Okay, so think of it like this. When I say give me the derivative, we can take a derivative over an interval, so that's like an average derivative, okay? Or we can take an instantaneous derivative. When it says find the average velocity, that's like taking the velocity over the interval from A to B here, okay? So hopefully that makes sense with the way that's set up there. All right. Let's see, we'll look at the notes and then we'll go down and look at the example up there. So when v of t is 0, you're stopped. Okay, your position's not changing at that time, at that instant. Okay, when v of t is less than 0, you're moving left or down. When v of t is greater than 0, you're moving in a positive direction, up or right. If a of t is 0, then that means you have constant velocity. Okay, so your acceleration is not changing at all. Now these two guys down at the bottom, these two guys are kind of critical. If you are speeding up when acceleration and velocity are both the same sign. That's what these two things here are saying in this. If you look at this, you'll notice that it says when a of t, so when acceleration is greater than 0 and velocity is greater than 0. Or you can also be speeding up when acceleration is less than 0 and velocity is less than 0. So when acceleration and velocity have the same sign, you're speeding up. The one below it says that you are slowing down when they have different signs. So acceleration greater than 0, velocity less than 0, or acceleration less than 0, velocity greater than 0. Then you are slowing down. Okay? Let's see, let's go back up and take a look at the example up at the top here. So it says let s of t be t cubed minus 6t squared be the position so that's position function, measured in feet of a particle. All right? And it says find the velocity, speed, and acceleration of t equals 1 and 2 and 4 seconds. Wow, they want us to do a whole bunch of them here. Okay, so velocity, speed, and acceleration. Okay, so to do velocity, we need a velocity function. So we're going to start off with v of t, which again is just a derivative of s of t, so that's going to be 3t squared minus 12t. So there's my velocity function. With my velocity function, I can do v of 1, v of 2, and v of 4, so I'll go ahead and do that right now. So v of 1, and I'm going to plug these in quick, because if I plug in 1, I just get 3. Plugging in 1, I get minus 12. So the velocity here, v of 1, is negative 9. Alright? Now, again, if you look on the left side, velocity always measured in feet per second, and this was in feet, time in seconds. So this would be negative 9 feet per second. Okay? That's velocity. Speed, on the other hand, speed equals 9 feet per second. Speed is always positive. Okay, velocity just tells me which direction I'm moving. So I do v of 2. I wanted v of 2. So I would do 2 squared is 4. 4 times 3 is 12. Minus 24. So this would be negative 12. Again, feet per second. But speed is going to equal positive 12 feet per second. Alright? And then finally the last one, v of 4. So 4 squared, where's my function? 4 squared is 16. 16 times 3 is 48. Minus 12 times 4, which is 48. So it equals 0 feet per second, which means my speed is also 0 feet per second. Alright? So that's speed versus velocity there. Okay? Then they wanted the acceleration. So to do acceleration, we need a function for that. So we're going to do a of t, which means we take the derivative of v of t. So that's going to be 6t minus 12. And again, they wanted a of 1, a of 2, a of 4. So a of 1 is going to be 6 times 1 is 6. 6 minus 12 is negative 6. And this is in feet per second squared. Okay. A of 2 is going to equal 6 times 2 is 12. 12 minus 12 is going to be 0 feet per second squared. And a of 4 will equal 6 times 4 is 24. 24 minus 12 is 12 feet per second squared. Okay? So that's velocity, speed, and acceleration at t equals 1, 2, and 4 seconds. Okay? Now, let's see, does it ask us for anything else here? Okay, it doesn't, but you know what? I'm gonna talk about something else while we're down here. Okay, so position is where you are. Where you are. Position is not how far you've gone, but it's where you are. So if I say my position on the x-axis is 4, that doesn't necessarily mean I've traveled 4 units. It means that I'm currently at 4. Okay, so position is where you are. So if I look at the position function, okay, if I look at s of 0, all right, and my position function, we had, well, I can rewrite it here. I've got plenty of room here. We had a position function, s of t equals t cubed minus 6t squared. So if I plug in 0 to that, you can obviously see I get 0. So s of 0 equals 0. Okay? So when I'm at 0 seconds, wherever I am at, okay, this is my starting point. That starting point may not be 0. It might be something else. It might be 4 or 6 or 8 or something like that. So at 0 seconds, I'm at 0 according to my position function. Let's look at s of 1. If I plug in 1 to the function, I get 1 take away 6, which is -5. So what have I done? I've gone -5 feet. That means I've moved to the left 5 feet in 1 second. Okay? If I do S of 2, and I plug in 2, I would get 2 cubed, which is 8. Now I'm going to have to write this down. So I have 8 minus 2 squared is 4. 4 times 6 is 24. So now I'm at -16 feet. So it doesn't mean that I've traveled 16 feet further to the left. It means that I've traveled 11 feet further to the left. Okay, so at 1 second, between 0 and 1 second, I traveled 5 feet to the left. Between 1 and 2 seconds, I traveled 11 feet further to the left. All right? And so if we do S of 4, I'm just using the same numbers that were up top there. If I do S of 4, I'm going to get 4 cubed, which is 64. Hang on a second here, guys. All right. So if I do S of 4, I get 64 minus 4 squared is 16. 16 times 6 is 96. So that's going to equal -32 feet. Okay, so again, what you kind of want to keep in mind here is this means I moved 16 feet further left, further to the left. Oops, left. So again, what I want you to realize is it doesn't mean I've moved -32 feet more. It means my current position is -32 feet. Okay? And then we'll do one more. We'll do S of 5. So if I plug in 5, I get, where are we at? 5 cubed, which is 125, minus 6 times 5 squared, which is 6 times 25, that's going to be 150. So this is going to equal -25 feet. Now this is hopefully where, again, this is making sense, but what does this mean? This means I've moved 7 feet to the right. So between 4 and 5 seconds, I stopped going left and I turned around and I came back and started going to the right, and I ended up 7 units further to the right than I was at 4 seconds. Okay? So kind of keeping all that in mind, what we're looking at there, let's take a look at velocity here. Okay? Because velocity tells me when I hit a max or a min or something like that. So take a look at this. If I look at my velocity function here, and our velocity function was v of t equals 3t squared minus 12t. If I set this guy equal to 0, so I'm looking for critical numbers now, there's no undefines, so if I set this guy equal to 0 and I solve it, 3t squared minus 12t equal to 0, I'm going to factor out a 3t, so that's going to leave me t minus 4, so I have t equals 0 and t equals 4. Alright? Well, t equals 0 is my starting position. Okay? And I already know what t equals 0 is. That's 0. Okay? So I know that, let's take a look. We're going to set up our number line here. So I know that 0 is a critical number, but again, is it a max or a min? We'll find out. And so t equals 4 was my other critical number. Alright? And so if I look at v of t, so let's choose, like t equals 1 here. If I plug in 1 to v of t, you get 3 minus 12, so this is definitely negative. If you plug in 5, you can see that, what do we got? We got 3 times 25 is 75 minus 60. This is definitely going to be positive. If we do t equals 5, this is positive. Well, what's that telling us? It's telling us something about its antiderivative, s of t, the position function. It's telling us that s of t is decreasing, and then s of t is increasing. All right? When we say decreasing, we're saying basically going left. Going left. When we say increasing, we basically mean we are going right. So therefore, we can say that at 4 seconds, we went from decreasing to increasing. Okay? Our derivative went from negative to positive. So again, this is at 4 seconds. So if you think about a graph, 1, 2, 3, 4, at 4 seconds, our derivative went from negative to positive. Now I don't know what it looks like, so I'm just going to do that. So, and again, what that tells us is that our position went from moving left to now moving right. And you can see that on the left side here. When we went from 4 to 5 seconds, we definitely changed direction and went around the other way. Okay? So hopefully that kind of makes sense in terms of what we're looking at here and gives you a little better idea of how position and velocity are related there. All right? So next one says v of t equals this function. Let v of t be the velocity of a particle in feet per second. So they're giving us the units here. Find the intervals on which the object moves left and right. Okay, so we just did a little bit of that in the previous example. So if I want to know when I'm moving left and right, I want to know when derivative is positive and negative. Okay, so we want to know v of t less than 0, v of t greater than 0. Here we go. So we need critical numbers. So we have 6t squared minus 42t plus 60. There's no undefineds in there because it's a polynomial function. However, I can divide out a 6 on everything. So I'm going to divide everything by 6. So this is t squared minus 7t plus 10. Just got a lot easier factor, didn't it? So we have t minus 5 times t minus 2. And so we have t equals 5 and t equals 2. So those are our critical numbers. Now what you want to keep in mind is because t talks about time, we don't ever go to the left of 0. So we always start at 0. So we've got our first critical number at 2, and then our next critical number at 5. And so I'm going to choose t equals 1, t equals 3, and t equals 6. And so we're going to look at v of t, what's happening with v of t, and that will tell us whether we are moving right or left or whatever. Okay, so here we go, plugging in 1. Now I'm going to use this equation right here to plug in 1. It's the easiest one. If I plug in 1, okay, 1 minus 5 is a negative value, 1 minus 2 is a negative value, and a negative times a negative equals a positive value. So this section is positive. All right. Well, what does that tell me about my function? It tells me that s of t, my position function, whether I'm moving left or right. So if v of t is positive, then I'm moving to the right. Okay, I'm increasing. So we plug in 3 to the function, we get 3 minus 5, which is a negative number, 3 minus 2, which is a positive number. Negative times positive equals negative. So this section's negative. So that tells me that my position is moving to the left. Okay? I'm now moving to the left. Let's see here. V of t equal to 6. 6 minus 5 is positive. 6 minus 2 is positive. That's going to equal positive. So this is positive. And now I'm moving to the right again. Okay? So it did ask for what intervals, so we should write something out nicely here. So we're going to say, let's see, I'm going to erase over here, scratch work. So let's see here. So we'll say the particle is moving to the right on 0 to 2 and 5 to infinity, because v of t is greater than 0, and the particle is moving to the left on 2 to 5 because v of t is less than 0. Okay? Alright, so it says if s of t is a position function and s of 1 equals 44, find the position function. This is an initial value problem. Okay? When they give me a function with an initial value, I can find the antiderivative and do a plus c here. Okay? So really what they're wanting me to do here is they're wanting me to find the integral of v of t dt. Okay? So that integral is going to be the integral of 6t squared minus 42t plus 60 dt. So the antiderivative of that, which is going to be the position function s of t, the antiderivative of 6t squared, you could do 6t cubed over 3, but that's going to turn out to be 2t cubed. The antiderivative of 42t is going to be 21, oops, sorry, I meant minus. It's going to be 21t, and the antiderivative of 60 is going to be plus 60t, and then our plus c. And so again, because they gave me a point 1 comma 44, all I need to do is plug that in. This is s of t right here for 44, and the 1 represents t. So here we go. S of t is 44 equals 2 times 1 cubed minus 21 times 1 plus 60 times 1. Oops, I forgot my squared on that t right there, so that should be 21 times 1 squared. Hopefully you caught that earlier, but hey, we caught it now, right? 60 times 1 plus c. Alright, add it all up. 44 equals, this is going to be 2, take away 21, which is going to be negative 19. Negative 19 plus 60 is going to be 41 plus c. Subtract 41 on both sides, and you get c equal to 3. Now, technically, in order to find the position function, we have to write the whole thing out again. S of t equals 2t cubed minus 21t, we'll remember the squared this time, plus 60t plus 3. There's your position function, just like our last unit right there. Okay? Alright. Let's take a look at part C here. Part C says, what is the average velocity? This is a key here. It doesn't say find the instantaneous velocity. It says find the average velocity of the particle on the interval from 1 to 4. Alright, so here we go. Average velocity. Well, average velocity, we have a formula for that. So average velocity is equal to S of B minus S of A all over B minus A. Alright, so that's one way to do average velocity right here. So if we just simply plug in the numbers, okay, so I'm going to need to know what S of 1 and S of 4 are. So I need to know S of 1, and I don't think I did that one yet. So I'm going to need to know S of 1. Where's my position function right here? So S of 1. So I got to plug in 1 to this function. Okay, this shouldn't be too hard. So this, you can see right up here, if I plug in 1 to part B here, that's going to be 2 take away 21, which is, negative 19 plus 60, which is 41, plus 3, which is going to be 44. If I did all my math right there, let me check my cheat sheet here. Yeah, I think I got it. And then I need S of 4, So I would have to plug in 4 to the function up here. Now, I'm just assuming that you can plug in 4 to this function because I'm going to cheat a little bit here. S of 4 is equal to 35. So if I plug into the average velocity function, I would do 35 minus 44 all over 4, take away 1. And that's going to leave me, what do we get on top? 35 minus 44, that's going to be negative 9 over positive 3, which equals negative 3. And our units here were in feet per second. So this is not instantaneous velocity, this is average velocity from 1 second to 4 seconds. So your average is negative 3 feet per second. Okay? Now, I want to show you something else while we're here. If you look at the fundamental theorem of calculus, the fundamental theorem of calculus says this. It says that the integral from a to b of some function, and I'm going to use v of t since we're using velocity in this case, v of t dt, v of v dt, is equal to v of b, because the integral of v would be s, right? S of b minus s of a. Now, why is that important? Because if you look at what we just did on the left side here, we just did s of b minus s of a. But we divided that by b minus a. So look at what happens when I divide by b minus a. If I divide this side by b minus a, that means that I can also divide the left side by b minus a. And the left side would actually be now written, instead of b minus a underneath, the left side would be written as 1 over b minus a. So what I'm doing is I'm taking the integral over an interval from a to b, and then I'm taking the average over that interval by dividing it by b minus a. Okay? Think of it as a slope. This is y2 minus y1 over x2 minus x1. That's what an average is. X1. Okay? Interesting the way that goes together, huh? Alright. It says, when will the instantaneous velocity equal the average velocity? Okay, now, instantaneous, now we're talking about v of t. Alright? When's that going to equal the average velocity? Well, guess what? We just did average velocity, and it was negative 3 feet per second, or negative 3 in this case. Alright, so we want to know when the instantaneous equals the average. Well, the instantaneous velocity is our velocity function that we started with. That's 6t squared minus 42t plus 60. And that's our instantaneous. When's that going to equal the average velocity? So what time are those two equal to each other? Well, to solve this, we're going to add 3. So we get 6t squared minus 42t plus 63 equal to 0. And we need to solve this. And we could try factoring this, breaking it down. I'm going to divide everything by 3 here. That's going to give me 2t squared minus 14t, 14t plus 21 equal to 0, and we might be stuck here in terms of trying to factor this. I don't think this is going to factor. So at this point we would have to go to a graphing calculator, and we want to find out at what point that this is equal to 0. So I'm gonna pause and pull up my graphing calculator. Okay, so you can see I've got my graphing calculator pulled up here, and I've got my equation punched in here, and I want to know when this thing's going to equal 0. Now, I don't know what my window is set at, so I'm just going to go to a standard window, zoom 6, And there we go. So you can see it hits twice, and yeah, it does hit a little bit past 2 in another area over here. So we're going to go to our calculate function. We want to calculate a 0 here. So we're going to calculate, it says give a left bound. So let's see here, if we start moving our cursor, where's the cursor going to be? There it comes, here we go. So a left bound, that looks good. And then a right bound for that 0. Looks good right there. And so it looks like my first 0 is 2.177. Okay, so my first one's going to be t equals 2.177. T is in time, so this would be seconds. You want to make sure you attach that on there. And then I'm going to go back to my graphing calculator and look at the other one. But the first thing I notice is when you look at this, take a look here. The scale on here goes by ones. So there's 1, there's 2, there's 3, there's 4. The second intercept is past 4 seconds. Now, why is that important to realize before I waste a bunch of time on an AP test here? If you look at our interval goes from 1 to 4. I don't care about this intercept that's over here past 4 seconds, because again, in our problem here, it says on the interval from 1 to 4. So even though there's 2 solutions on the calculator, there's only one solution that they're looking for on the interval from 1 to 4. Okay? So you just want to kind of keep that in mind. All right? And we'll go on to the next one. All right. So it says, what is the average acceleration of the particle? So now, again, we're back to average acceleration, okay? So average acceleration equals, to do an average, you use the function before it. So this is v of 4 minus v of 1 all over 4 minus 1, okay? So I need to do v of 4. I know that v of 4 is equal to, and if I plug 4 into v, now don't use the v, right? You got to go way back to v that we started with. Okay, so we got to go back up to the top. If you plug in 4, you're going to end up with negative 12. If you plug in 1 to v, you get 24. So to do average acceleration, I would do v of 4, so that's going to be negative 12 minus 24 all over 4 minus 1. So that's going to be equal to negative 36 over 3, which is negative 12 feet per second squared. Okay? So that's how we would write that answer. And then it says find the acceleration function of the particle. Well, that's just taking the derivative of the velocity function. So a of t, again, just a reminder, that equals v prime of t. Alright, now v prime is floating around here somewhere. You can see it at the top of your page here. Okay, so I can see v prime right here in part B. So I'm going to take the derivative of that guy right there. So this is going to be 12t minus 42 for v prime of t, or a of t. Okay, that's all that part F asks for. And then part G says, when will the average acceleration equal the instantaneous acceleration? Well, average acceleration, that was negative 12. And instantaneous acceleration, that's our function that we just did. That's 12t minus 42. So I need to solve this. So I'm going to add 42 to both sides. That's going to be 30 equals 12t. We'll divide out 12 on both sides. So that's going to be 12 and 12. So t is going to equal, what do we get? 5 over 2 if we simplify this. So 5 halves seconds. And actually we could leave it as 30 over 12 seconds as well, and nobody's going to say anything. Okay, so that'd be a perfectly fine answer as well. Alright, last piece here. It says, on what intervals is the particle speeding up or slowing down? Now remember, on the first page we talked about speeding up and slowing down. Speeding up means that a of t and v of t, v of t, same sign. Same sign. They're either both positive or both negative. They're slowing down if a of t and v of t, different signs. One positive, one negative. Alright? So we need to figure out how to deal with this. So we need to find out, number one, where both of those functions are equal to 0. Alright? So we're going to start with a of t. A of t was equal to, we just did a of t, what did we come up with here? A of t was 12t minus 42. So we need some critical numbers for this because we got to know where it's positive or negative, and that's what our critical numbers tell us. So this is 0 equals 12t minus 42. Add 42 to both sides, equals 12t. We'll divide out the 12. And so t equals 42 twelfths. I think I'm going to simplify it this time just so I can graph it on the number line. This is 7 halves, or 3.5. Alright, so that's our critical number for a of t. Now, v of t, I think we did some criticals back here, didn't we? If we look back here, look at this, part A. We already did v of t in part A. So all we got to do is copy that piece down here and see how the two line up. Okay? So that's the next thing I'm going to do. I'm going to actually start off with v of t on the top. So v of t, so copying what we had from the top, v of t was starting at 0, and it had a critical number at 2 and another critical number at 5. And so at 2 we were positive, so this was, I'm actually going to write this so you can see it: positive, negative, positive. Alright, and then we'll do a of t right underneath that. So we'll do a of t. Now I'm going to try and keep everything lined up nice and neat here. So I'm going to still start at 0. Nice line, huh? So now 3.5 is going to be right here. Okay, so this is 7 halves, but I'm going to write it as 3.5 for now, just so you can kind of see where it falls. So we need to find out where a of t is positive versus negative. So I need to plug in, you know, like t equals 1 into a of t. So a of t, if you plug in 1, you get 12 minus 42. So this is definitely going to be negative. If you plug in, say, 4, you get 12 times 4 is 48, and 48 minus 42, this side's going to be positive. Okay? And again, the whole idea is, where are they both the same sign or different signs? So this gets a little bit tricky sometimes trying to figure this out and trying to scale this exactly, but what I'm going to do is I'm just going to draw some lines here, okay? Because I know that in these sections here, and you'll notice I'm drawing a line at every critical point, because that's where my positives and negatives get separated. Okay, so you can see in this section, all right, we're positive and negative. In the next section, we're negative and negative. But in the third section here, we're negative on top, positive on bottom, so we're different signs in those yellow sections, and we're same signs in the non-yellow sections. So that's what's going to separate and tell you whether you're speeding up or slowing down. All right? So we're going to say the particle, and I'm just going to start with the first one where they're opposite signs, is slowing down. On the intervals 0 to 2, and I'm going to go back to an improper fraction, 7 halves to 5, because a of t, and you could say this one of two ways. You could say that they have different signs. You could say that a of t is negative and v of t is positive, but I'm just going to say because a of t and v of t have different signs. Different signs. All right? And then I need to mention that the particle is speeding up on the intervals from 2 to 7/2 and 5 to infinity, because a of t and v of t have the same sign. All right? Okay. Whew, boy. So that's the end of your page. Hopefully I had enough room to finish that up right there. It looks like we still got a couple of pages left. So I'm going to take a break and get a drink of water, and I'll be right back. Alright, so our next problem here is interesting because it actually looks exactly the same as the previous one, but they start us off with the acceleration function on this one instead of the velocity function. So there's a of t, 16 minus 12, and it says let that be the acceleration of particle in feet per second squared. If v of t is the velocity function of the particle and v of 1 equals 3, here's an initial value problem again. It says find the velocity function, okay? So we're going to start out by doing that, finding the velocity function. So when they're doing this, what v of t actually equals, again, is the integral of a of t dt. All right? So v of t is equal to the integral of 6t minus 12 dt. So we need to anti-differentiate that. So v of t is going to be equal to 6t squared over 2, which leaves 3t squared minus 12t plus some value of c. And now I can plug in. So I can plug in 3 for v of t and 1 for t. So that's going to be 3 times 1 squared minus 12 times 1 plus c. So we're going to end up with 3 equals, let's see here, we've got 3 minus 12, this is negative 9 plus c, and if you add 9 you get 12 for c. That's interesting. Okay, so v of t, which I'm assuming we're going to need later for something else, is going to be 3t squared minus 12t plus 12. Alright, that's our first piece. It says find the intervals on which the object or the particle moves left and right. Well, I know I'm moving left and right again if v of t when v of t is left when v of t is less than 0, right when v of t is greater than 0. So we need to find critical numbers and set up a number line again. So we're going to take our velocity function, which we just had there. We're going to set it equal to 0, 3t squared minus 12t plus 2. You'll notice there's no places where v of t is undefined, so all I need to do is set it equal to 0. I can't divide anything out here, so, or can I? Plus, oh, you know what? This is 12 plus 12. I missed that. Okay, so plus 12. I can divide some stuff out here. Perfect. Plus 12. So I can divide everything by 3. So that's going to give me t squared minus 4t plus 4. And I can factor that into t minus 2 times t minus 2. Interesting. So I only get one solution here. Okay. So we go over to our number line. Here's 0. Here's 2. And here's v of t. So I'm going to plug in 1 to v of t. And again, I'm going to use the simplified form. I'm using this guy right here. So if I plug in 1, this is going to be negative times negative, which is going to be positive. And if I plug in 3, it's going to be, looks like I'm going to be positive both places. If I plug in 3, I get positive times positive. So I'm always positive. So v of t or the particle, I should say, the particle moves right on 0 to 2 and 2 to infinity because v of t is greater than 0. Okay? That wasn't too bad. It says, what is the average acceleration? Again, remember, an average always uses the equation before it, the antiderivative before it. So if I'm going to do average acceleration here, I need v of t. So I've got that. And I'm going on the interval from 0 to 5. So I need v of 5 minus v of 0 all over 5 minus 0. Now, take a look. The 0 should be easy here. V of 0, here's my velocity function right up here on the right side. If I plug in 0 to that, I get 12. So, actually I'm going to do this. So I'm going to do v of 0 equals 12. But then I still need v of 5, which I'm just going to do it quickly here. V of 5, if you plug in 5, you end up with, let's see, this is going to be 75 minus 60 plus 12, and so v of 5 turns out to be 27. Alright, so here we go, let's plug them in. 27 minus 12. Now 5 minus 0 in the denominator is just 5. So this is 15 over 5, which equals 3. Average acceleration, what are we talking about here? We're talking about feet per second squared. Average acceleration. Okay? Feet per second squared. Alright? So you got to remember the correct units on there as well. Alright, here we go. Next one. When will the average acceleration equal the instantaneous acceleration? Okay, so instantaneous acceleration, we were given that back here in the original problem. There's instantaneous acceleration way up at the top. We just found average acceleration to be 3 feet per second, and it was positive. So when our average, that's 3, equal our instantaneous, that's 16 minus 12. Add 12 to both sides, you get 15. Divide out 6 on both sides, and you get t equals, we can divide that out pretty easy. Divide by 3, it's 5/2 seconds. So the average acceleration will equal the instantaneous acceleration at 2.5 seconds. All right? And now we go to x of t. If x of t is the position function, and x of 1 equals 5. Here we go again, ladies and gentlemen. This is an initial value problem. Find the position function. All right? So again, x of t, if I'm trying to find x of t, that's like taking the integral of v of t dt. So x of t is going to equal the integral. Remember, v of t, we found that way back. It was 3t squared minus 12t plus 12 from part A dt. We need an antiderivative for this, and so we would have x of t equal to, oh, look at how nice, that 3 is just going to jump right back up in there, t cubed minus 12t squared over 2 is going to be negative 6t squared plus 12t plus c. Let's plug it in. Alright, x is 1, or t is 1, and x of t is 5. So here we go. 5 equals 1 cubed minus 6 times 1 squared plus 12 times 1 plus c. Alright, on the right side we're going to get 1, take away 6 is negative 5, negative 5 plus 7 plus 12 is 7 plus c, subtract 7, so this time c is negative 2. And again, we do need to write out the function. X of t equals t cubed minus 6t squared plus 12t minus 2. There is our position function. Alright, let's keep going. What is the average velocity of the particle? Okay, so average velocity means use the function before it. So I'm going to use the position function from 0 to 5. So I need x of 5 minus x of 0 all over 5 minus 0. Now x of 0, you can see that that's going to equal -2. That one's pretty easy. X of 0 equals -2. X of 5, however, this one gets a little more complicated. If I plug in 5, I get 125 minus 6 times 25, which is 150, plus 60 minus 2. And if you do the math on that guy right there, it turns out that this is 33. So now we can plug in 33 minus a -2 all over 5. Well, that's 35 over 5, which equals 7. This is velocity, so this is in feet per second. All right, so my average velocity over the interval is 7 feet per second. And again, when will the instantaneous equal the average? Instantaneous velocity, that is instantaneous. Where's my velocity function? My velocity function was 3t squared minus 12t plus 12. When's it going to equal the average? Well, we just found the average to be 7. So if we subtract 7 on both sides, we get 3t squared minus 12t minus 5 equal to 0. If we, not sure if we can factor that. Interesting. So we would have to graph this on our graphing calculator again. Okay, so if I go to my graphing calculator again, I'm going to go ahead and just graph this while you're here, because I can change this other one pretty easily. This is going to be 3x squared. We have minus 12t, so I'll just scroll over and change this. Minus 12t, and our last number is plus 5. So we'll go 5, and then we'll delete the last one and graph. Now this time we're going on the interval 0 to 5, so you'll notice right away that when we start to look at this, 5 is way over here to the right, so we do have 2 points this time that we need to look for. So we would do second, calculate, we're going to do a 0 again, we need a left bound, so we're going to get close, that's a little too close, and then we'll do a right bound, and we'll hit enter again, and it's going to tell us that at 0.472. Alright, so 0.472, so t equals 0.472 seconds, and if we do the other one using the same steps, we get t equals 3.528 seconds. Alright? Alright, where's the particle speeding up or slowing down? Alright, speeding up or slowing down, again, we're looking for when they're both positive or negative, or when the signs are different. Now again, we did v of t up top. So v of t, when we did that one in the very first part, we got this chart. We had 0 and 2 as our critical numbers, and v of t was positive and positive, if you remember from up top. So now I need to look at a of t, but I haven't done a of t yet. A of t is what we were given. So I need to come over here. A of t was given as 6t minus 12. So we set that equal to 0, 6t minus 12. And if you add 12 and divide by 6, you can see t equals 2. Interesting. It came out to 2. Alright. So I'm going to go over here, and I'm going to go 0 and 2. And I'm going to plug in some numbers for a of t, so I'm going to choose 1. If I plug in 1, you can see hopefully that 6 minus 12, this is going to be negative. If I plug in 3, that's going to be 18 minus 12. Right over here on the left is going to be positive. And so this one's pretty easy to see. It just pretty much splits right down the middle right here. And we've got 2 intervals, one where we're speeding up and one where we're slowing down. So the particle is slowing down, doing the first interval, slowing down on 0 to 2 because v of t and a of t have different signs. And the particle is speeding up on 2 to infinity because v of t and a of t are same sign. Okay? All right, we got through that one a little bit quicker. What do we got left here? Wow. It's a long lesson, isn't it? All right, so it says a ball is thrown upward from a cliff, 160-foot high cliff with an initial velocity of 48 feet per second. Use the equation h of t equals negative 16t squared plus v sub 0, that's velocity, t plus h sub 0, that's your initial height. Okay, so it says find the position equation. Now, usually a position, we think of it as s of t or x of t. In this case, I'm going to use what they gave me. I'm going to use h of t because we're talking about height here, so we're talking about up and down. So this would be negative 16t squared plus v sub 0, that's my velocity, so it's going to be 48 feet per second, and it was thrown up, so the 48 stays positive, 48t, plus h sub 0, which is your initial height, that's going to be 160. So there's my position equation. I want to find the max height. Well, what does that mean? It means find where h of t goes from increasing to decreasing. Okay, that's going to give me the max height. So I need h prime of t. We could also call that h prime of t, which is also v of t, because remember, the derivative of position is velocity. And so if I take the derivative of this, I get negative 32 times t plus 48. And if we set that guy equal to 0, we get negative 32t plus 48. I'm going to add 32t to both sides, equals 48. Divide out the 32. Now again, if this was an AP test, I would probably just leave it as t equals 48 seconds, if that makes any sense. But I'll go ahead and simplify this. This turns out to be 3/2 seconds. Alright, now go back and read the question. It says find the max height. This is the time at the max height. So for me to find the max height, I got to plug this guy in. And so now I've got some work to do. So I go back to my height function, not my velocity function, my height function, and I need to find h of 3/2. So here we go. We get negative 16 times 3/2 squared plus 48 times 3/2 plus 160. Guess what? AP test, feet. Done. Okay? And we could go on and continue to simplify this, and I would encourage you to do that just in case you need to. But this should turn out to be 196 feet. Alright? Okay. By the way, did you know there was an easier way to do that problem? A heck of a lot easier way. Because this h of t function up here, this is just a parabola. So why don't I just find the vertex of the parabola instead? Why don't I do, you remember vertex of parabola? This is t equals negative b over 2a. So if I do negative b, that's negative 48. Negative 48 over 2 times a, so that's 2 times negative 16. There's my time right there, 3/2 seconds. That was easy, wasn't it? That's all a vertex is. It's the velocity function. Alright, find when the ball hits the ground. So we want to know when the height is 0. Okay, so we want to know when h of t equals 0. Let's see if we're going to need a calculator for this one or not. Negative 16t squared plus 48t plus 160. Well, I know I can divide all that by negative 16, so I'm going to start there. Negative 16 would leave me positive t squared minus 3t minus 10. And can we factor that? This is going to be t minus 5 times t plus 2. That looks good. So we get two solutions here. We get t equals 5 seconds and t equals negative 2 seconds. Wait a minute, we can't have negative time here. So that dude's gone. And so we have one solution. It's going to take the ball 5 seconds to hit the ground. All right? And then it says find the velocity of the ball at the time it hits the ground. Well, what does that mean? It means find the instantaneous velocity. Find me v of 5. Well, we have a velocity function up top in part B. It was v of t equals negative 32t plus 48. So I need to find the velocity at 5. Let's see how fast this thing was traveling. Oops. So we want to do v of 5. That's going to equal negative 32 times 5 plus 48. All right. So v of 5, if we do a little bit of math here, we end up with the number negative 112 feet per second. That seems pretty fast to me. Okay, now remember, that's velocity. That tells me that it's coming down, which makes sense, because at the 5th second it hits the ground. And so the velocity should be negative if it's coming down. However, on the other hand, the speed of this thing is 112 feet per second. All right? Like I said, that seems pretty fast. I'm not sure I'd want to get hit by that guy. All right. Wow, we are still not done yet. This is a monster lesson here. Okay, here we go. The piecewise function at the right represents the velocity of a particle for the interval 0 to 5 in meters per year. Okay, I like knowing what my units are. Determine on what intervals. Okay, so this is the velocity. So right away, you can see the little v of t up here. I like a big v of t. I want to know exactly what I'm looking at. Determine on what intervals the particle is moving to the left and right. Justify your conclusions. Okay, so the particle, when we're looking for left and right, what we're looking for is where v of t is. If your velocity is positive, then you're moving to the right. If your velocity is negative, you're moving to the left. So you can see in this whole section up here, v of t is positive, so we're moving to the right. And then down here in the green, we're negative, so we're moving to the left. So we could say something like the particle, all right, is moving right on 0 to 3 because v of t, you could say, is positive or greater than 0, and left on 3 to 5. Oops. Getting a little ahead of myself there. 3 to 5 because v of t is less than 0. Okay? So we justified our conclusion, and then it says find a of 1 and a of 3. Let me see if I can scroll. Do I need to? Okay. So a of 1. Now, if you remember, a of 1, what they're asking for here, this is the same thing as asking for v prime of 1. So really what they're saying is find the derivative of v of t when t equals 1. So what does that mean? It means find me the slope when t is equal to 1. Well, check it out. I'm going to put a point up here at 1. That's close enough to 1, right? Now, what does that mean? It means that I need the derivative right there. Okay? It doesn't mean give me the y value of that part here, because if I just give the y value there, okay, if I say that at 1 I'm at, we'll just call it 3, what I'm really saying there, you got to remember, this is the graph of v of t. So I know that v of 1 is equal to 3. But a of 1 is the derivative at t equals 1. So when I'm sitting at that green point right there, what's my slope? Okay, so I know that I can use this point and this point at the ends, and if I count up and over, this is going to be up to and over 2, it looks like. So a of 1 is actually 1. Okay, so the slope there is 1, and so we would say that this is 1, and we were in meters per year. Meters per year. All right. What about a of 3? Let's go over to 3. So we're gonna, let's erase these guys. We'll put a point over here at 3. A of 3. Look at that. Now again, keep in mind, v of 3 is equal to 0. But that doesn't mean a of 3 is equal to 0. That means find me the slope there. And again, we're on a straight line here, so I can go from the top. That's going to be down 4 and over 1. So a of 3 is going to be negative 4 meters per year squared. Okay, so because we're talking, oh, did I forget the squared on the first one? Yes, this is acceleration, isn't it? So these should both be squared right there. 1 meter per year squared. All right, I was thinking velocity on that guy. All right, so got to be careful there. It's easy to miss. All right, next question. It says determine the speed of the determine if the speed of the particle is increasing or decreasing at t equals 1, t equals 2.5, and t equals 4. Okay, so really what we need to know is what are the values of v and a at those values. So v of 1, we already talked about that up top. V of 1 was equal to 3, and a of 1 was equal to 1. Okay, so the speed is increasing, and it didn't say justified, but you can see they're both positive, so that's why the speed's increasing. Okay, so at 2.5, v of 2.5, oops, 2.5, we're going to have to find that one, and a of 2.5, so I'm going to have to go back up and use my graph for this. So v of 2.5, so here's 2.5, and it looks like I'm up somewhere around here if I draw my line straighter. So that v of 2.5 looks like it's 2.5, if I'm right there. So velocity at 2.5 seconds looks like it's 2.5. Now, how do I know what acceleration is? Again, I need the slope there, but I don't really care about the slope, even though we've already found it because we're on a straight line right there. The slope is negative 4 meters per year squared, but I do know it's negative. So because it's negative, I could just say a of 2.5 equals negative, and therefore I could say it's decreasing, but I already know that it's negative 4, so the speed is decreasing. Okay, and then v of 4, one more time here, v of 4 equals, and if we go back to our graph, v of 4 is going to, wow, holy cow, that's way down here. That looks like it's probably negative 4, and again, a of 4 is still negative 4, it's still on the same line. So this is negative 4, a of 4 equals negative 4, so the speed is, those are both negative, so the speed is increasing. Whoo-wee. All right, last question. Explain why a of 2 does not exist. All right, so and I think this is supposed to say why the limit of a of 2 does not exist. So if you take a look at this, look at 2. All right, so at 2, we're back up here at the top. I'm just going to put an X right there. Now, the limit of v of 2 exists because the graph comes up to 4 on the left and up to 4 on the right. But a talks about the derivative. And the derivative, as you approach 2 from the left, the derivative here, so we could say a of t here is equal to 1, and a of t here on this side is equal to negative 4. We calculated both of those earlier. So that's why the limit does not exist at a of 2. Okay? So the limit as t approaches 2 from the negative side of a of t does not equal the limit as t approaches 2 from the positive side of a of t. Okay? All right. Wow, finally finished. Geez, we're out of here on this one.